and thank you for joining us for the next part of this session. My name is Catherine Bohr, and I am a professor in the Department of Food Science, but I'm also the Ronald P. Lynch Dean of the College of Agriculture and Life Sciences. And I'd like to welcome you yet again to this really exciting series of conversations that we're having this morning. And it's my honor now to introduce to you our next speaker, and I'll say a few words before I get to that point. And I'd like to really start with an introduction of the fact that as we look at the impact of technologies across the food system, they certainly extend way deeper than advanced equipment. And IBM is using an approach to their thinking that is made possible by big data, and the goal is to find opportunities to design safer and more sustainable food systems. So what is the promise of big data? The promise of big data is the potential to be able to leverage those data to guide us to make better decisions across the entire food system, from decisions on the farm to a better understanding of the food that we're actually going to put into our mouths, to gain efficiencies in the systems of today, and certainly to think in a forward way about designing the systems of tomorrow. We are very, very fortunate today to have Dr. Robin Lougee here. And Robin is uniquely qualified to be here with us today to share her thoughts on these issues. She is IBM Research Division's Innovation Strategist for Consumer Products and Smarter Agriculture. And that's an expansive responsibility that aligns so perfectly with our focus here today. She is an industrial research scientist with a strong track record of delivering innovation to IBM and its customers. Now, Robin led the first team of research scientists in IBM's On-Demand Innovation Services organization, and she pioneered the creation of COIN-OR. That's an acronym that stands for Computational Infrastructure for Operations Research. And that is an open source foundry for computational operations research. And it was the first IBM open source initiative of its kind. And Robin led its growth into an independent nonprofit that has served the scientific and business community now for more than 10 years. Robin has been elected to many different offices. She's on the board of Informs, she's chair of Informs Computing Society, and she's served as president of the Fora of Women in ORMS, that's operations research. I'm personally deeply appreciative of Robin's commitment to the Cornell Institute for Food Systems and our global summit, and I know, for example, that last March she flew in overnight from Europe and braved what was a blinding snowstorm to join us at the IBM Cornell meeting, where initial plans for today were just beginning to be formed. So it is my distinct pleasure this morning to introduce you to our keynote speaker, Dr. Robin Lougee, as she presents Big Data Throughout the Food System, Driving Decisions, Designing the Future. Please join me in welcoming Robin.
Thank you. Thanks, everybody. It's a pleasure to be here. And it's a rare opportunity to have such an esteemed group across the entire value chain. So I thought, what should we do? A little common research together. So I want to take a poll. So if you get out that cell phone, that laptop, that tablet that you have, and I want to ask you, in one word, what do you think the biggest opportunity, the biggest challenge is to global food systems? So don't be shy. We're going to do a real quick word count, and this will help me also as we have the discussion, not just today, but later on in this workshop and going forward. So you may have noticed that you can actually do input more than once. There's nothing that stops you if you're really passionate. All right, this is good. The number gets bigger the more people that have the same word. This is really good. So we have integration, perception, climate, consumer diversification, distribution, geopolitical. No one's done greed yet. Oh, this is great. You know, these are complex, interconnected issues. And just a spoiler alert, I don't have any answers. But I'm reminded of something my colleague's wife. So Jonathan Eckstein, who works down at Rutgers University, his wife is actually a social worker. And she tells her clients, if something's not working or you're not getting where you want fast enough, don't try harder. Don't try to do more. Try to do different. And so what I'm hoping I can do today is maybe spark a few ideas to talk about what we might do different and the role of big data in that. All right, so you may have noticed I'm from IBM. So I want you to shout out the first word that comes to mind when I say IBM. All right, I was listening and I didn't hear anybody say food or agriculture. Okay, so you may be wondering, what is someone from IBM doing here at the Cornell Global Food Systems Summit, let alone, speaking in this spot? And I hope I can answer that question. So this is one of those very simplified views of the players in the global food systems, which of course doesn't include the consumers or the government agencies. And you'll notice IBM's not up there. We don't grow, we don't process, we don't package, we don't distribute, we don't sell food products. But we're in this space. We're the information technology, infrastructure, and business solution providers to these guys, these players, and many other industries. So as we think about holistic thinking, I'd like to invite you to think holistically about other things we can learn from industries, and in particular, from the challenges companies like IBM have had in integrating many different business processes and systems and looking at what's needed in those space. So this is one of my favorite pictures of the global food systems. And when Julie was, kind of dinging on the simple picture, I thought, oh, I'm going to work this one in. Because the complexity of this space can be overwhelming. It's difficult to know how to get your fingers on the edge of it. This is from John Ingram from Oxford University, is how I first saw this picture at an earlier workshop that was American Institute of Mathematics and NSF funded on multi-scale modeling of the global food system. And they introduced me to many of of what I know about food systems, and I just like to acknowledge their work in this space. So let me start off by telling you a little bit about me so you have better context for what I'm going to say, and hopefully introduce some new concepts into our thinking about food systems and the global food system. So I come from IBM, but I'm in a separate division, the IBM Research Division. So has anybody participated in a food or climate or conference with someone from IBM Research there? Any interactions? I'm glad Nick raised his hand. So let me tell you a little bit about IBM Research. IBM Research is more like a university than you might imagine, in the fact that part of our mission is independent scientific research, but we're really an innovation arm for the IBM Corporation. About 1% of the population of IBM is PhD research scientists and staff at this division, which spans 12 sites, 6 continents, and our next lab is going to be opened in South Africa. I sit at the T.J. Watson Research Center, just about 4 hours south, conveniently, in Yorktown Heights, New York, where we have about 1,500 scientists out of the approximately 4,000 people in the division. We take innovation very seriously. IBM has been a leader in being awarded patents for the last over 20 years now. Although we're 1% of the population, we account for more than 25% of the patents. We have 5 Nobel laureates. It's a very esteemed place, and I'm delighted that they still allow me to work there. We have more variety of disciplines than you may think. I'm a mathematician by training, computational mathematics, operations research. We have material scientists. We have physical scientists, environmental scientists. We have PhDs in physics, in behavioral economics, and cognition. It's a treasure trove of different talent so that we can bring together different thoughts to solve problems for our clients. Now, when you think about IBM, you may have thought about computers. And you may have thought about business services. We don't get involved in selling computers or in those services unless it's a challenge that can't be solved. So if there's a consultant who's done something 10 times before, 100 times before, that's wonderful, and they go do it for IBM. Our division is looking for those challenges which no one else has solved and which will unlock a lot of transformational value for our clients, like the project that Nick was telling you about earlier, which we're really very proud to have been a part of. So one thing we do every year, and part of the innovation we deliver to the IBM Corporation, is we try to give a roadmap of what's going to happen so that IBM and its clients can plan appropriately. Imagine trying to predict 10 years out what's the next transformation going to be. So in the 1990s, would you predict the web? Right? Or if it was like 2007, would you have predicted the impact of the iPhone? This is a challenging process that we go through. We run it for the better part of a month, and the output is a major deliverable from the Senior Vice President of Research to the board. It's delivered in over a 6-hour meeting. It's very intense, and it actually shapes IBM Corporation. It's a pre-strategy exercise. It changes the acquisitions we make, the fundings that we invest in. And I wanted to share with you a little bit about the recent evolution of that process and innovation, because I think it has a lot to do with food systems. Back in 2012, I had the opportunity to lead this global process. And many people were talking about the amount of data when they said big data, or how fast the data was coming in and the need for streaming, or even the variety of different types of data, social data, GPS, sensor data. But there was something about the nature of data that we called out that was, we had to find a word that started with a V, right? So it's veracity. But it's the fact that in decision support systems, there's this well-known adage, which I think you're all familiar with: garbage in, garbage out, right? And these new sources of data had something fundamentally different than the transactional type systems that computers have been based with. And that was they were very fuzzy. For example, this vacuum cleaner sucks. Good or bad, it depends on the context. There's lots of examples where people were finding instances of their GPS system showing the truck was in the middle of the ocean or in New York, right? The garbage trucks. And this was because of the error in GPS. So enterprises were having to struggle with big data and this managing uncertainty at scale in order to drive insight out of it. The next year, data came up again. Now, sometimes topics keep popping up, but this was kind of unusual. People were looking at social, mobile, cloud, big data, and analytics, but we looked at the interconnections among those and came to define what's now been called a system of engagement. How all those systems interconnect and what's the implications, especially for transforming roles like chief marketing officers, who now can precision target you with offers when you go shopping and recommendations. And I'll give you an example of our next trend, as systems of insights. Have you ever noticed when you go to shop for like Netflix, and they make these great recommendations about movies, and they mine all that data and information to tell you, you might like this movie. It's a very powerful tool with a lot of deep intelligence. Have you noticed when you go to buy an airplane ticket to, say, Mexico or Cornell, it's after you bought the ticket, you often see the offers to go to the same place? Not so intelligent, right? Right. So the real value seems to come from locking both those systems of engagement with your historical systems of record. And it's in that middle part, we call it the system of insights, which needs three things. It needs the engine to deliver the insight, it needs the cloud, and it ultimately needs the data. And then unprecedented, 4 years in a row, data comes back. And what we're seeing now is continuation of this evolution and the fact that data is going to disrupt entire industries. And I see that disruption happening in food and agriculture. So we're all overwhelmed by data, right? It's a huge opportunity. But what you may not know is that we're only at the beginning of this hockey stick of data that's coming at us. Does anyone know what a zettabyte is? It's a big number, right? No, it's a 1 followed by 21 zeros. It's very big. We're just here at the very beginning of this. And this data isn't all the same. It has a lot of different attributes, which implies different things for how we harness insights out of it and compute with it. The structured data, the stuff that's well-defined, is very small. All this unstructured data is the pictures. You know, my tweets, the GPS sensors, and they have very different requirements. You know, one thing that's really different about this generation, and I have an 18-year-old daughter, so I'm experiencing this firsthand, is just how much they're capturing and using multimedia images, you know, the Snapchat. Huge amount of that data is there, and it's very valuable. But interestingly, it's not captured anywhere. You know, 90% of the data created over the last 10 years was never captured or analyzed. Now, this is really valuable stuff, but we're not using it. You know, the reason is because it's so big, we don't have the bandwidth to send the data back to the central systems to process it. It's orphaned. It's just a flitters away and it's never used. So think about that and the proliferation of all these mobile devices. You may have more than one with you. And imagine now, we can't move the data, and moreover, the computing capacity of our smartphones all combined is going to exceed all the servers in the world. There's really fundamental implications for how we look at deriving insights for food systems and opportunities for us. So one of the benefits of, I hope I can bring to bear in this discussion today and which we continue, is the fact that IBM, not being particularly in food, servicing many industries, can also look across the industries and share innovations that are happening elsewhere and bring them back to the conversation. And I think life sciences and medicine is a great example of what's happening for agriculture. You know, it used to be in your medical record, you know, the stuff the doctor would write down in a paper, there's about 4 terabytes of data, and that's how they would do all the diagnosis by these cohorts. We've all been through this process of having to go through the standardized tests to figure out finally to get to the treatment that you wanted in the first place. Genomics data, right, immensely valuable. It's about 6 terabytes of data. But the exogenous data that's all around us, our social data, when we eat, how much we sleep, are we walking, all the things that are captured by our Fitbits or the sensors in our phones or the chatting we're having with our mom once a week, you know, that's all exogenous data. That's where studies show most of the value is when it comes to your outcomes on health. 60% of the value comes from there. So think about this. And I look at this, and as a mathematician, and I think, doctor? Well, a farmer is a doctor, right? He's a doctor for the field, or a doctor for the cow, or a doctor for a plant. So all this stuff that's happening in medicine, it's just this personalized medicine that's being kicked off. It's the exact same fundamental transformation that we're doing in precision agriculture. We need that exogenous data. And I'm so fortunate that Nick went first and so eloquently spelled out, you know, all that, the terrain data, the elevation data, the soil data, the weather data, the seed data, the pesticides, disease data. We want all that context so we can make, and what he asked for was in real time decisions on the field. So this is what's coming for us, and I'm very excited about it. But there's a problem with all this data, and that was also pointed out by Nick, is that how do you extract insights from all this stuff? You know, the surprise of the correlations you find. Correlations are great, but you want causality, right? And especially for farmers, because what they did last year when it was a dry year may not work so well next year when it's a wet year. So maybe more than other industries, we need to understand what this causality is. And so in healthcare, what's happening. In healthcare, we've ushered in this new cognitive system, what we call a new cognitive systems era, using processes that think like human to augment doctors' intelligence to deliver personalized medicine. Did anybody see the Jeopardy show where a computer played against humans? So Watson's system, a few of you? So we invented a computer to play the game of Jeopardy. We did this not because we thought that this was a big business for IBM, right, selling a Jeopardy computing system, but because the ability to take a corpus of language and understand it to the degree that we could know how certain we were about it. Remember I talked about dealing with uncertain data? And then figure out how to bet, and then actually beat humans. We thought that was a fundamental technology that was needed in the world. So we're using these new cognitive systems, which are now being trained with medical data, to deliver decision support to to doctors. It doesn't replace them, but it augments their intelligence. And I think agriculture and food systems needs the same thing, because just as one doctor can't possibly read all the literature that's being created today about a specific disease in order to deliver you the best health care, in the same way an agronomist can't keep up with all the literature and all the events that are happening. And we have the ability to do this, and it's coming faster than we may even know. So let me just say that you're, I suspect, all aware of the global trends that are so well articulated in the popular press about the demand increasing, about changing consumer habits, our need for sustainability, our need to deal with increasingly volatility in prices, food safety. Interestingly, no one put food safety up on the World Cloud. I thought that might pop up. Against the global dynamics that are happening in businesses. But I really think this wealth of data is the way we can start thinking differently. So I want to quickly tell you about two things that are happening at IBM in this area, where we're trying to think differently thanks to new data. So one was mentioned in the introduction, has to do with food safety. And we're partnering with Mars on a new consortium called Sequencing the Food Supply Chain. So food safety, huge topic, really affects everybody in the industry when it happens, not just the particular company. But how do you do it? How do you know what's in your food? When milk is commingled, when wheat is commingled, how can you tell the consumer what they want to know about what's really in there? Are we going to try to track and trace it to that extent, or barcode it somehow, store all that information? Those techniques are all good and needed in their place, but thanks to the genomic sequencing, we think we can think differently in this space with our partners in Mars. We think the metagenomic content of the food can provide a sort of surveillance, a fingerprint, if you will, of what happened. So for example, suppose you get something from your supplier and they say, yes, this has always been under the agreed upon refrigeration limits, right? Perhaps the driver left the truck and didn't notice a blip on the screen. Not intentionally, but if there was a spike, how would he know in order to report to you? Well, it's pretty likely, our hypothesis is that the biome, the bacteria, the group of different bacteria living in that food would be a little bit different than the normal sample. So we're trying to be able to describe the envelope of the biome to figure out what's normal in food so that we can detect events like that, events that no one knows what they don't know, so that people all across the food supply chain can then go and investigate and take appropriate action. Now this requires a huge informatics infrastructure that's really beyond any one company. So that's why we invite everybody to come join us in this consortium to take on this very different approach to food safety. So that's one. Second has to do with this level of dealing with spatial temporal data. So all those layers of spatial temporal data, the kinds that Nick were talking about, It's really a new challenge for the analytics community to deal with because they're uncurated. The dirty truth about analytics is that we spend about 70% of our time trying to take the data and putting it into a form where we can use it, right? Being able to do the joins, being able to derive the inconsistencies between different raster types. So we think there's a lot of time to value. We can get time to value to be had if it were possible to curate all this data, to put it in a holistic, already uniform sense, right? Where all the joins have been made, where all the gaps have been dealt with, where all the precision issues have been worked out. So it's ready for everybody to be able to use it for their analysis. And this requires fundamental advances in data science to be able to deal with the uncertainties in these kind of data sets. So this is another area where we're working. And in fact, the team that was working on the Gallo project has been working on this, and we have some preliminary systems. So those are two ways, using the genomics data and using the spatial temporal data. We're trying to think differently about systems and how they can help the global food system. I couldn't help but sneak in a couple extra projects of the dozen projects we have at IBM Research. We're working on drones. I'm very excited about drones because of the ability to collect data at a temporal and spatial resolution we've never had before, both for raw science and to give insights to farmers. The challenges here are very significant. People are using drones, but they can't get the data off the drones to process it. And then there's the issue of whatever sensors you have on this new mobile platform. If it's image data, how do I analyze that data? And how do I analyze it over the epochs that a farmer would need, the multiple seasons to get good insights? And the other one I wanted to talk to you about a little bit was this work that we're doing down in Africa, which you may have seen profiled on the BBC, called Easy Farmer. And again, this just highlights our investment and interest in the Internet of Things and being able to use mobile technologies to deliver insights to farmers and connect the different players. In this case, the type of irrigation is not a drip irrigation, but it's a tank irrigation. It's dealing with farmers who can't afford to stay all day on the farm. They go into the cities. They want to ensure that their crops are well taken care of and coordinate systems. So we're trying to develop this proof of concept in order to help them do that. There's a huge opportunity in Internet of Things to monitor everything from gates on the farms, to cows, to wearables, to monitor their health, in addition to the weather information you may be thinking about, and even new types of sensors that we're developing. So let me just close and say that I believe that these new kinds of data in big data and cognitive systems, the data that's IoT enabled, is a great opportunity for us to be thinking differently in food systems in a way we haven't in the past, to be able to mine it, to answer questions that we're not going to be able to understand because this system is so complex. It's so hard to get your arms around. But computers, we can use computers to distill information and insights for us from it. And secondly, I hope I've convinced you why IBM might be interested in this space. I thank you for your time, and I'd just like to invite you to let the world know about this discussion we started at the Global Food System Summit by tweeting, and thank you very much for your time. So I tried to leave a few minutes for questions, so I think we have time for one or two. Craig?
Yes. One of the discussions going on in the agricultural community where the data that's being collected by our machinery manufacturers or our seed companies is who owns the data? And I wondered if you would comment on that discussion and that issue.
Yeah, I'm glad. Yeah, I think a lot of the companies have come out and said the farmer owns the data. I'm not sure if the farmer rents the land from the landowner who owns it, but the farmer owns the data. And what's interesting to me about that is in medicine, if for medical reasons, people will give their data and it's anonymized, right? We don't know it's you. But we suffer from this challenge in agriculture because all our data is geospatial. So one of the challenges, and I meant to mention it, and I'd like to throw it out to you, is how can we anonymize geospatial data? You know, is there topological mappings? Where's that mathematics community for this probably a little bit crazy idea of being able to anonymize the data at the scale we need, farm scale, sub-farm scale, in order to do the analytics that everybody wants? So I think the farmers own it. I think they're looking to monetize it. One of the other challenges I didn't talk about in this space that I think is fundamental to our success is really envisioning new business models. You know, we get so tied up in technology, I think a lot of times it's the business models that'll make the big breakthroughs. And so farmers are looking not just to agriculture co-ops, but information co-ops to monetize the data they own, because everybody is squeezing the farmers, right? This is one of the reasons the farmers don't want to share the data, because there's these two pressures on them. On the one side, if they do better, the input companies want more. And on the other side, if they don't do too good, then if they're renting land, they won't be able to get any more because of the contract. So what is their incentive to share? Yet we all need that precious data in order to do our analytics, to be able to, you know, help improve the system. So I think the onus is on us to try to think really creatively to solve this, and I would welcome any ideas that you have. Hope I answered your questions. Okay. Anybody else?
Hi, Robin. It was a nice talk yesterday with you. I'm struggling with, you know, what you presented is so huge, and so I'm struggling with where exactly, what scales would be of interest in IBM. And a lot of what I saw was much bigger scale. And an example of another scale would be just the system of insights is a nice phrase that you use. So I'll use that to say that the system of insights can be useful for precision, not in agriculture at that kind of spatial, but precision in product and process design within an industry. And there we have this wealth of data, like physical properties, chemical properties, microbiological properties, nutrients, and those things can make a huge difference in terms of the efficiency of product design, process design. We could clearly see which products fall in which category. And this data right now is not available on all, and certainly not available as a system of insights. Yeah. But is that a scale that you have any interest?
Absolutely, absolutely. You know, this is so challenging. You know, these taskmasters here give you such a short time to talk, right? I need a week. I need a week. So, IBM research, you know, I mentioned how big it is. We have so much work going on. I really just picked two topics. We have a material sciences group. So all the special material sciences we developed for state-of-the-art semiconductors, who would have thought? They're useful other places too, like in antimicrobial polymers. You know, just to give you an example, a large beverage company CEO told our CEO when she asked, "What's your biggest challenge?" And they said, "Citrus greening." Now, who would have said that to IBM, right? But we took on the challenge, and our molecular modelers, you know, helped look at how to actively interfere with the bacteria. In fact, I'm not the only one from IBM here today. My colleague Christine Kretz from the Computational Biology Center is here and can tell you even more detail about this work. And then the question is, how do you deliver this to the plants in a way that, you know, is healthy for them? And we have a group that does customs antimicrobial polymers. They do hydrogels. They do all sorts of stuff which I can only describe at the highest level of detail, which may be why I didn't pick it today, but very interested in not just micro scale, but nano scale, and even quantum, you know, looking at quantum computing and quantum scale. You know, I recently heard the director of the computational biology team talking about our ability to manufacture these nanoscale pillars, if you would, so that we could sort, size of molecules as they went by to separate small from large on that side, which allowed us to be able to do sampling at a much smaller scale than ever before. So to answer your question is that these are really important challenges, and definitely there's a lot of interest in that as well and shouldn't be neglected. So thanks. No other questions? Hey, Nick.
I have one, if you don't mind. With the work you've done with Mars, for example, you mentioned Mars earlier. Fantastic work, working on the genome for cow, and I think it really set a standard for all of our commodities, really, in terms of crop commodities. Still, the limitation of the application of that work is in phenotyping. So we can punch through the genotyping fairly efficiently. Phenotyping is always, I think, our bottleneck in developing the kind of relationships and clear understanding of the data that we wish. This system is a lot the same way from my perspective. We're able to collect vast amounts of data. We identified that with the PAIRS, with the PAIRS platform. But we still lack the intimate knowledge of the ground truthing to really integrate that data in order to really gain key insights and the kind of logic models that you develop for Watson for our economists. So I just wonder, from IBM's perspective, research perspective, are you spending time thinking about that space and developing automated phenotyping and ground truthing methods in order to kind of equal the velocity that we're able to generate on data collection mode from the plant? Can we do those same things on the ground? And if we can greatly enhance our ability to understand the data.
Yeah, that's a great question. And so one project comes to mind. We were recently awarded a Department of Energy grant with Purdue under the Terra proposal. I don't know if you know. So it's Purdue University, IBM Research, and Cicero, the scientific organization in Australia. And the idea here is DOE. So they want better biofuels. It's looking at sorghum. But the idea is, in order for us to do better breeding, we need this phenotypic information, right? How do we collect it in a way that's more automated? So Purdue will be flying the drones and putting the sensors on the equipment. And the team at IBM is developing the deep machine learning techniques in order to automate the identification of the phenotypic information needed to do the breeding cycle. So did that answer your question? Yeah, I think, from IBM's perspective, we're not well known in ag. We have a lot of different point projects, right? Like, we do our best work because we're computer scientists or scientists at heart when we partner with someone who has the data, right? Because we have no farms, no cows, no vineyards. We partner with someone who has the data and the subject expertise, and it's that combination together. So I think the example at Gallo is the best example I know about how to do innovation. And then there's the question about how do you commercialize it and, the value for a company like, IBM. And I sometimes have difficulty in the space because of the lack of understanding of the sector, myself, to articulate, the value for IBM, who's an enterprise-to-enterprise company and looking for those businesses that will be $1 billion. I believe they're there. I know they're there. Particularly when we look at the diseases that are running through, pork or understanding the rumen of the bovine. I know they're there, but how do I, a mathematician, really understand that and articulate? And I think this is where you can help me, understand that space. One last quick comment is my professional society informs Institute for Operations and the Management Sciences. It's like a math geeky kind of organization. We have a big prize. So operations research started out of the military. That's why we have a name that no one can understand. It was like, delivering the analytics to figure out, what's the minimum number of bridges to blow up so the enemy can't get you kind of problems, right? So we have a huge prize. We call it the Super Bowl of practice, where we look for that company that's made outstanding contribution and impact. And do you know who won it last year? Does anybody know? It was Syngenta. Syngenta. I have never seen them at that conference in my 21 years at IBM. They won the prize because they teamed up with some consultants and had done some really innovative things. And bless their hearts, they've decided, because we need more computer science and analytics people in the space, to run a contest. So we're going to have the Syngenta Crop Challenge. I'm helping to work on the judging to try to attract all those people who know nothing about the biology, but have those other skills that are complementary, and hopefully try to spark this discussion that I think is beneficial to both sides. So maybe we could do more of that kind of work in reaching out to the computer science or the analytics community to let them know about these amazing challenges that are needed for machine vision or other things. Okay, thanks, Nick. All right.
I have a question.
Oh, sure.
Yeah, so this framework that you just outlined, is it open source?
Oh, the pairs framework?
Because it sounds like if you could get more input to be able to do more work, could that be a solution?
Yeah, you know what? I'm very interested in open source, like GoDan and the other, because of my background in starting an open source a consortium at IBM, where we realized that people were publishing a lot of mathematics, but they weren't sharing their code because it was just too difficult. And so it was really impeding our progress. So I do look at this space and think, what if everybody shared their data, right, and their algorithms? It's not a panacea. From IBM's perspective, we're a for-profit company, right? So we need to have the business case to do it. So for example, Apache, which runs on our servers, IBM actually helped them form a corporate entity so that we could deploy their code on our machines. We've been very active in it, but at the end of the day, there usually has to be some sort of business reason to support the open source strategy, though we do things, for philanthropic reasons. So to answer your question, I hope that addresses a little bit your question. It is not open source. We use open source. We support open source. We have people that we pay just to work on Linux kernels and things, but that particular one is not. Any other questions? Well, if you have a question, I hope you'll grab me at the next break or as we continue the summit. Thank you very much.